Day 2 of 4.3, slope-intercept form. Once again, what is slope-intercept form?
Y equals mx plus b.
Y equals mx plus b. You guys definitely need to know that. You need to have that memorized. The slope-intercept form of a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. The variables m and b are called parameters of the equation because changing either value changes the graph of the function. So if my b value changes, the graph of the function is going to look different. If the m value, my slope, changes, the graph is going to look different from what it looked like previously. Everyone okay with that? That's why they're called parameters. If I change them, the look of the graph changes as well. We good with that?
Yeah.
Okay. What is a constant? If I ask you, what is a constant, what would you tell me? You got to say something. A constant is a number without a variable.
Oh.
So if I had 3x plus 5, what would be my constant there? 5. That's the number without the variable. Okay? When we're graphing, we also have these things called constant functions. A constant function is a linear function of the form y equals b. What does b represent?
Y. Oh wait, no. B?
The y-intercept, more specifically. I heard someone say y, but I was looking for y-intercept. So, if I've got a function of the form y equals b, is there any x in that equation at all? No. We've kind of talked about equations like this before, but we've never known them as constant functions. Constant functions where b does not equal 0 do not cross the x-axis. Does anyone remember what type of a line a constant function will form? Horizontal. It has a slope of 0. It's horizontal. It's only crossing the y-axis. It's not crossing the x-axis at all. Okay? The graphs of constant functions have a slope of 0. We've talked about that with Slope Dude. Remember he said this is 0 fun on the long flat part? Whenever we talked about the acronym HOI, that was a horizontal line. The O was a 0, means that the horizontal line has a slope of 0. The domain of a constant function is all real numbers, and the range is b. What is domain? Talked about this last semester.
Like the x value.
Domain is my set of x values. So the domain, or my set of x values of a constant function, is all real numbers.
Harvard's calling my name.
What is the range?
The y value.
My set of y values. I only have one y value in my range for a constant function. It's whatever my y-intercept is. That's the only y value, that's the only number in my range. Any questions about any of this information? Okay with that? Okay, let's go ahead and move on. Graph a linear function with a slope of -3/2 and a y-intercept of 4. Graph a linear function with a slope of -3/2 and a y-intercept of 4. Anyone know how to graph given the slope and the y-intercept? Anyone? Yep. Okay. Anytime I'm given the slope and the y-intercept, or I'm given an equation in slope-intercept form, which is essentially me being given the slope and the y-intercept, the very first thing I need to graph is the y-intercept. That's going to be my starting point. So it tells me my y-intercept, or my b value, is 4. What is a y-intercept again? Where my graph crosses the y-axis. So where am I going to graph this 4?
4. On the y-axis.
On the y-axis at 4, right? I know that is the exact point where my graph's going to cross the y-axis because that's what it tells me. It tells me that's my y-intercept. So when we're graphing with slope and y-intercept, you will always, always, always graph the y-intercept first. Okay, that's always going to be your starting point. Our slope helps to give us more points. Okay? Slope is what over what? Rise over run. So the numerator, the top of the fraction, that's my rise. That's either up or down movement, right? That's vertical movement. If it's a positive, it's telling me to go up. If it's a negative, it's telling me to go down. We okay with that?
Yes, sir.
The denominator is my run. That's my horizontal movement. It's either going left or right. If it's negative, it's telling me to go left. If it's positive, it's telling me to go right. I see a little bit of an issue here that we might get confused on. I've got a negative in front of my fraction. And I've got to use my slope to get more points on my graph here. How do I know if I'm going up or down 3 or up or down 2 or left or right 2 if my negative is in front of my fraction like this?
Good question.
It is a good question, I know. Any ideas? Where does my negative go? With the 3, with the 2, with both?
Hello.
It is not with both. If it was with both, a negative divided by a negative gives me a positive. Is this a positive slope? No. So it does not go with both. Here's the answer. It's kind of a trick question. It doesn't matter where it goes. Negative 3 halves is the same thing as negative 3 over positive 2, which is also the same thing as positive 3 over negative 2. A negative divided by a positive gives me a
Positive. Or negative.
negative. A positive divided by a negative gives me a negative as well. So these two things are the same thing. We're actually going to end up using both of these. Okay? So let's do negative 3 over positive 2 first. So my rise is negative 3. Since it's negative, am I going up or down? Down how many? 3. My run is positive 2. So if it's positive, am I going left or right? Right. How many? 2. So down 3, right 2. Where do I go from?
Interesting question.
Where do I go down 3, right 2 from?
2 right down.
Well, but from which point? Where's my starting point? What?
Y.
The y-intercept. The origin is not your starting point. The y-intercept, since that's already a point on my line. So from this point, I'm going to go down 3, right 2, and put another point. 1, 2, 3, 1, 2. Are we okay with that movement? Down 3, right 2.
Yep.
From this point, I'm also going to go down 3, right 2 to get another point. Everyone okay with that? 1, 2, 3, 1, 2. And I'm just going to keep going until I can't fit any more points going this direction on my graph. Down 3, right 2. Down 3, right 2. I can't get any more after that because going down 3 would go off my graph. But we're going to put an arrow on our line. That slope is going to continue forever and ever and ever and ever in that direction. Okay? Whenever we're graphing in slope-intercept form, I want you to fit as many points on your graph as you possibly can. So I can fit more points going this direction, correct? What's the opposite of going down 3 and right 2?
Up, right, up.
Left 3.
Left
2.
2, which is what this one is telling us to do. Positive 3 is telling us to go up 3. Negative 2 is telling us to go left 2. From our y-intercept once again. So up 3, left 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Get as many points as you can in that direction as well. Have I fit all the points that I can fit on my graph?
Yeah.
Yep. Once I get all my points, I can connect my points with a line. Draw my arrows. This is a linear function. There's no things telling me that I have to stop my domain at a certain point, so I know my line is going forever in either direction. Okay? Now, your homework assignment today, you're going to be doing this on your computer. So it's going to tell you to graph a function, and it's going to give you 4 different graphs to choose from. You just got to choose the correct one. Sometime next week, I'm going to give you paper pencil assignments to where you have to graph on your own, because I think you need to be able to do that as well. Be able to graph it using all the points. Okay? So next week, whenever you get the paper pencil assignment, I always tell students to use their ID edge as a straight edge to get you a nice clean line through all your points. Okay? Questions on example 4 here? Okay. Example 5. Graph 12x minus 3y equals 18. 12x minus 3y equals 18. This whole lesson's about slope-intercept form, correct? Yeah. So if it gives you something that's not in slope-intercept form, what do you think you need to do before anything else? If it's not in slope-intercept form, but we're talking about slope-intercept form, I probably need to get it in slope-intercept form. So how do I get an equation in slope-intercept form that's not already there? What's an easy way to think about it? I'm solving for y. Trying to get y by itself. Okay? What would be my first step here to get y by itself? Subtract 12x. Whatever I do to one side of this line, my equal sign, got to do to the other. We okay with that? 12x's cancel out. What do I have on the left-hand side now? Negative 3y. Are 18 and 12x like terms? Nope. So how would I write it? 18 minus 12x. Remember, the computer was really iffy, and it wants the x term first. So I'm going to put the x term first and do negative 12x plus 18. We okay with that? Last step to get y by itself. Divide by negative 3. On the right side, what gets divided by negative 3? Every term that's on that side. Negative 12x divided by negative 3. Positive 4x. Positive 18 divided by negative 3. Negative 6. Are we okay with my equation in slope-intercept form here? Okay. It wants us to graph it, so it's probably a good idea to go ahead and identify the y-intercept and the slope. What is my y-intercept here? What's going to be my starting point? 6. Negative 6. There is a difference between 6 and negative 6. If you use positive 6 here as your y-intercept, your graph's going to be completely wrong. Okay? Questions on how we got our y-intercept? What is my slope here? Don't include the x with it. 4. The slope is always the number that's being multiplied by x. Okay? For graphing purposes, we like our slope to be rise over run. We like it to be a fraction, correct? If my slope is ever a whole number, how do I make a whole number a fraction? Put it over 1. So 4 over 1 is my slope. We okay with that? So, graphing in slope-intercept form, what's my starting point? What's my starting point? What do I need to graph first? Negative 6, the y-intercept, right? So find your y-axis, go down 6 and put a point. When we're graphing in slope-intercept form, always graph the y-intercept first. Otherwise, you don't know where you're supposed to start. Okay? Okay, my slope is positive 4 over positive 1. So positive up top tells me I'm going up or down. Up 4. Positive in the bottom tells me I'm going left or right. Right 1. So for my slope, from my y-intercept, I'm going up 4. Right 1 and putting another point. 1, 2, 3, 4, 1. We okay with that? Up 4, right 1. I'm going to keep doing that until I run out of room. I want you to fit as many points as you can on the graph. Okay? 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Any questions getting points in this direction? What's the opposite of going up 4 and right 1? Down 4, left 1. In other words, I could just change both signs of my numerator and denominator on my slope. Is this still positive 4?
No. Yes. Yes.
A negative divided by a negative gives me a positive. Still the same thing. Still equivalent, right? It just helps me get more points on my graph. So I can go down 4 left one from that y-intercept. 1, 2, 3, 4, 1. Once again, when you're doing this by hand on paper, I want you to get as many points as you can on the graph. Okay? Once I fit all the points that I can, use your straight edge, use your ID to get a straight line. Put your arrows on your line. And there's my graph of 12x minus 3y equals 18. How are we feeling about this? What do we graph first? Y-intercept. Use your slope to get more points. Okay? Questions? Can I move on? Okay. Graph. Y equals 2. What kind of a function is this?
This is a. I can think of it. Hold on. It's a. Constant function.
Constant function.
Yeah.
This is the form y equals b. Or just y equals a number, right? Is there any x at all in my equation?
No.
No. It's not a vertical line. It's a horizontal line. Okay? We can still think about it as using slope and y-intercept. What is my y-intercept? 2. The y-intercept is always the constant when it's in slope-intercept form. What's my slope here? 0. It does have a slope.
Oh yeah.
It's a slope of 0.
My fault.
Or 0 over pretty much any number you want it to be. Okay? 0 over 5, 0 over negative 2, 0 over 10. Doesn't matter. It's just 0. Okay? So, graph the y-intercept first. Put a point at 2 on your y-axis. We know it's going to be a horizontal line, so I could just draw a horizontal line right here through there. Let's look at it with the slope, though. The rise is 0. So do I have any vertical movement at all? No. So I'm not going up or down at all, but I'm going right 5. And I could go left 5 as well. But either way, it creates this nice horizontal line going through 2 on the y-axis. You could use Hoy to graph this. I know it's Hoy because it's y equals a number. Which axis is it crossing?
Y.
The y-axis at 2. Put a point at 2 on the y-axis. What does H stand for? Horizontal line. Draw a horizontal line through that point. Okay? Questions on example 6. Anytime it's y equals a number and there's no x in there, it's going to be a horizontal line going through the y-axis at that point. We okay with that? Questions, comments, concerns? Can I erase and move on? Here's your assignment. 4.3 homework number 2. Are there any questions about the recording before I end it?